Hello students, welcome to my YouTube channel. Today we are going to continue with Introduction to Trigonometry exercise 8.3. So we have the first question. Express the trigonometric ratios sin A, secant A and tan A in terms of cot A. Okay. So now here for this problem, I am going to consider the following figure. So now here I have taken a triangle ABC, right angle triangle, wherein we have angle B as 90 degree. Okay, so we have taken angle B as 90 degree. So then AC will become the hypotenuse, and then since they asked you, we need to find a value of sin A, we need to find the trigonometric ratios of sin A, secant A and tan A. I'm going to take angle A as a consideration. So angle of consideration or reference angle. So now when I take A as a reference angle, that means so BC will become the opposite side and AB will become the adjacent side. Okay, right? And then what I do is I'm going to take cot A as X because they asked you express all these ratios in terms of cot A. So take that cot A as X. Now in my next step, I write it as equals to x by 1, which in turn is nothing but by the definition of as per the sides, this is nothing but adjacent by opposite side. Okay. So now what I do is, so now we have, I'm going to write this adjacent by opposite. So adjacent, I'm going to take it as x and opposite, I'm going to take it as 1. Okay. Now, in the right angle triangle by Pythagoras theorem, so in the right angle triangle ABC by Pythagoras theorem, we have AC square plus AC square is equal to AB square plus BC square. Okay. So taken AC square is equal to AB square plus BC square. In my next step, what I do is I'm going to write what is AC. So what is AC? AC will be nothing but square root of AB square plus BC square. Then we can write it as AC is equal to square root of x square plus 1 because AB is x. So AB square will be x square and BC is 1. So BC square means 1. So and then we are writing it as AC is equal to root of x square plus 1. Okay. Now what I do is I'm going to write these trigonometric, I'm going to find the trigonometric ratios sin A, secant and tan A. So for the first thing I need to take is sin A. So let us take sin A. So as per the definition, sin A is nothing but opposite by hypotenuse. Okay, which is nothing but I can write it as 1 by root of x square plus 1. Or I can substitute this x with cot A because they asked you express all these trigonometric ratios in cot A. So you have to replace this x with cot A. So now we have x square. So x square will become nothing but cot square A. Okay. So x square will become cot square A. So that means I am going to write it as 1 by root of cot square A plus 1. Okay. And then we have secant A. Secant A is nothing but hypotenuse by adjacent. That is the definition by sides. So now that means I can write it as, so what is hypotenuse here? Hypotenuse is root of x square plus 1 and adjacent is x. So I can write it as x square root of x square plus 1 whole over by x. Okay. Or I can write it as, so just replace this x with cot a. So that means you will get the numerator as cot square a plus 1 by x is cot a. So root of cot square a plus 1 by cot a. And then I have tan a. So tan a definition is opposite by adjacent. So that means I can write it as, so just replace these values, and we have already, what is opposite? Opposite is 1 and adjacent is x. So that means I can write it as, so that will be nothing but, you can write like this. So 1 by x, first we write it. So I'm going to write it as 1 by x, which in turn is nothing but 1 by cot a. So that is our answer. Okay. Now I go for the next question. Okay, let me go for the next question. I have this. Write all the other trigonometric ratios of angle A in terms of secant A. So this is similar to the first problem. So let us see how we can do this problem. Okay. For this, what I do is I am going to consider a figure. Okay. So first we are going to consider this figure. Okay. And here I have taken secant A as x. Okay. So secant A as x, and which is nothing but it is x by 1. So x can be written as x by 1, and then I am going to write it as hypotenuse by adjacent. So secant A is hypotenuse by adjacent, which is nothing but AC by, so AC by, and we have adjacent is AB. So AC by AB. Okay. So now we can fill up those the values. So I can write hypotenuse as x and adjacent, that is AB as 1. Okay. Next, what I do is I am going to consider the right angle triangle ABC and apply the Pythagoras theorem. Okay. So let me write it. So in right angle triangle ABC by Pythagoras theorem, we write AC square is equal to AB square plus BC square. Okay. Next, I can replace AC. So AC can be done as x square. Okay, AC square will be x square. And AB, what is AB value? AB value is 1. And BC value, what is the BC value? So BC value is root of x square minus, so BC square we need to find out. So now that means I can write like this, x square equals 1 square plus BC square, or I can write it as BC square is equal to, in my next step, I can write it as BC square equals x square minus 1. Okay. Or we can write it as BC is equal to, or we can write BC is equal to square root of x square minus 1. Okay. Then I am going to write the trigonometric ratios. Okay. Now I take the next step now. So sine A. So sine A definition is nothing but opposite by hypotenuse, which is nothing but. So now here you need to know that opposite are written as root of x square minus 1. So same thing. So BC is nothing but x square minus 1. So that means we can write root of x square minus 1 by x. I can replace this x with secant A. So that means you're going to get it as secant square A minus 1 by secant A. So wherever x is there, replace it with secant A. Okay. Then I go for the cos A. So what is cos A? Cos A is nothing but adjacent by hypotenuse, which is nothing but. So now adjacent value. So what is the value of adjacent? Adjacent value is, so we have, let us say adjacent value, it is 1. And then hypotenuse. Hypotenuse value is x. Okay. So that means 1 by x. So now 1 by x is nothing but, that is 1 by secant A. Okay. And then I'm going to write tan A. So tan A definition is opposite by adjacent, which is nothing but, I can write it as root of x square minus 1 by 1. Or see, you can write 1, or if you can ignore that also. Okay. So that means I can write it as root of secant square A minus 1. Okay. That will be our answer. Then we have cosecant A. Cosecant A is nothing but hypotenuse by opposite. So now I can write it as, so what is the value of hypotenuse here? As I told you, hypotenuse is x, and then opposite value, opposite is root of x square minus 1. Okay. So now I'm going to write that. So x by root of x square minus 1. I replace this x with secant A. So that means I can get secant A by root of secant square A minus 1. Okay. Then I can take the cot A value. So cot A ratio is nothing but adjacent by opposite. So adjacent by opposite is nothing but 1 by root of x square minus 1, which is nothing but 1 by root of secant square A minus 1. Okay. Right. Now this will be, all these are the trigonometric ratios in terms of secant A. Then I am going to take the third question. Choose the correct option and justify your choice. As the first question, 9 secant square A minus 9 tan square A equals to. So we have the four options here, 1, 9, 8 and 0. Okay. Now what I do is, so now here I am going to take the question. What is given? 9 secant square A minus 9 tan square A. That one, it's equal to. Okay. Now you know that secant square is nothing but 1 plus tan square A. So secant square is 1 plus tan square A. I can rewrite secant square as 1 plus tan square A minus 9 tan square A. Okay, minus 9 tan square A. Or it's equal to, I can write it as, so 9 into 1 is 9 plus, and again this one 9 into tan square is 9 tan square here. So I'm going to write 9 tan square here, and then minus 9 tan square here. Now 9 tan square here, 9 tan square here cancels, right? So that means you get the value as 9. Okay, this is your answer. Right, children? Now I go for the next question. I have the next question as follows. So I've taken this question. 1 plus tan theta plus secant theta into 1 plus cot theta minus cot theta equals to 0, 1, 2 and minus 1. All these are the four options we have. Okay, let us see which is the correct answer for this. Okay. Now what I do is, I am going to express this tan theta, secant theta, cot theta and cosecant theta in terms of sine and cos. That is the best thing that you need to do here. Okay. So now all these things you should know. Only how do you get to know all these, like we should do in this way, that way? So you need to practice. So for trigonometry, you need a lot of practice. Only then you can expertise in this particular uh, subject. Okay, so very, very important. You need to practice. At least you need to practice 3 to 4 times. Okay. Now, what I can take is, so here we have the first thing I need to write is, so now we have 1. So let us write that we have 1 plus, then we have sine theta plus cos theta. Okay, because tan theta is sine theta plus cos theta, plus, and then we have 1 by cos theta. Okay, so this is for the first thing. Okay, the first term, the first expression part, we have 1 plus sine theta by cos theta into plus 1 by cos theta. Okay, I'm going to enclose it with brackets. Then we have the next one. I write it as 1 plus cot theta. So cot theta is nothing but cos theta by sine theta minus, then cosecant theta. So cosecant theta is nothing but 1 by sine theta. I am going to enclose this also with bracket. Okay. And then, so let me put equal sign here. Then what we have to do is, you notice that cos theta is there in the denominator. See here, cos theta, and here we have sine theta, sine theta. Right, children? So now what I need to do is, I make sure that even this 1 also is written as an equivalent fraction, wherein you will have denominator as cos theta. Okay, that means to say, what I do is, see here, just take this expression here, that is, okay, and 1, I write it as cos theta by cos theta. So 1, I replace it by cos theta by cos theta. Similarly, 1 here can be written as sin theta by sin theta. Okay, so now let us take this again. See here, 1, I'm going to replace it with sin theta by sin theta. Then, now here what I do is, I'm going to write the denominator first. Okay, first let me write the fraction here. I'm going to write the cos theta. So because common denominator is cos theta, then what about the numerator? So numerator, you'll have cos theta, okay, plus you have sin theta plus 1, okay, right? And I can enclose it, whole of it, with bracket. Similarly, we can write this on the left, on the right part, we have sin theta. So plus cos theta minus 1 by sin theta, because sin theta is the denominator, you have sin theta common. So, or the same denominator, you can write it and then just add the numerators. So numerators, you have sin theta plus cos theta minus 1. Okay. Next thing I have to do is, now cos theta into sin theta. Now you're going to, you're actually, there's nothing, no operations present in between these two brackets. So that means it's just a multiplication. So that means what I do is, I can write it as, see here, if you look at it, it is something like this. A plus b into a minus b formula is there. See, something plus something, something minus something. Here something is nothing but cos theta plus sin theta, and something minus something. So something is simply sin theta plus cos theta minus 1. Okay. So now what I do is I can write as cos theta. So let me first write a fraction here, then it will be easy for us to write. So I'm going to write this cos theta plus sin theta whole square minus then 1 square. Okay, minus 1 square. And denominator, I can write it as cos theta into sin theta. Okay. So cos theta plus sin theta whole square minus 1 square my whole over by cos theta into sin theta. Now here this is an identity. You have to use the formula a plus b whole square. A plus b whole square formula. What's the formula of a plus b whole square? We have a plus b whole square. Let us write the formula. So now here a plus b the whole square, which is nothing but a square plus 2ab plus b square. Okay. We can write in this way also, or you can write it as, so first only you can write the square components. Okay. And then followed by 2ab. Okay. So now what will happen here? Okay, now let me write it. So it's equal to, write the fraction here. Now numerator becomes a square. So a square is cos square theta plus, then what is b square? It is sin square theta. Okay. And then plus 2ab. Plus 2ab means plus 2 into cos theta into sin theta. And then you have minus 1 also. Because how you got minus 1? Because minus 1 the whole square is minus 1 divided by cos theta into sin theta. And here you should note one thing. I put a dot here. Okay, so instead of writing this into sign, I can put a dot sign. So this will avoid confusion between x and multiplication sign. So that's why better to use dot to notate multiplication. Then what I do is I'm going to write a fraction here. Now you know that cos square theta plus sin square theta is 1. Okay, so let me write that 1 plus. Then you have 1 plus. So 2, 1 plus. So you have like this 2 cos theta into sin theta minus 1 by cos theta into sin theta. Or now here 1 and minus 1 gets cancelled. Okay. So now it gets cancelled. What will happen now? So you will be left out with in the numerator as 2, how much? 2 cos theta sin theta by cos theta into sin theta. Or it's equal to cos theta sin theta gets cancelled. So you'll be left out with 2 as the answer. Okay. Next question we have is secant A plus tan A into 1 minus sin A equals to. So we have four options: secant A, sin A, cosecant A, and cos A. So now I'm going to take the question. Okay. So secant A. So secant A is nothing but 1 plus 1 by cos A we have, okay. Secant A is 1 by cos A, and then plus, then we have tan A, is nothing but sin A by cos A, okay. Going to enclose with brackets. Then we have 1 minus sin A, so let us write that. So 1 minus sin A, I'm going to write it in the bracket. And then here in the denominator, I'm going to write it as 1. Okay. So the given expression is written as 1 by cos A plus sin A by cos A, bracket, then 1 minus sin A by 1. Then we can combine the numerator part. So that means actually you have 1 plus sin A into 1 minus sin A. So we can write like that. So I can write it as, let me take the same expression here. But this time I'm going to make some changes here. So I'm going to write it as 1 plus sin A, okay, by cos A, and then 1 minus sin A into 1 minus sin A by 1. Now, the numerator we have 1 plus sin A into 1 minus sin A. It is like A plus B to A minus B form. So that means I can write it as 1 minus sin square A. It is like A square minus B square formula. Okay. So that means, so numerator becomes 1 minus sin square A, and then denominator I write cos A, or we can write it as, what is cos square 1 minus sin square A? 1 minus sin square is nothing but cos square A. Okay, so I'm going to write it as cos square A. So cos square A by cos A. Then, so the reason for this is, you can write here reason, you can mention here. So 1 minus sin square A is nothing but equals to cos square A. Now cos square A and cos A, it goes one time. So the powers can be cancelled here. So I'm going to cancel like this. So cos A entire thing I cancel here, but here I'll just cancel 2 will become 1. So that is cos A. So it will become cos A. That's our answer. So cos A means the option is D. D is the option here. Then I have the next question. I have the fourth question. 1 plus tan square A by 1 plus cot square A equals to, we have the option secant square A minus 1, cot square A, and tan square A. So now what we do is we have to take that. So let us see how it can be converted. Okay, now we know that 1 plus tan square A, 1 plus tan square A is secant square A, and 1 plus cot square A is cosecant square A. Okay, so let us write that. So let us write. So it's equal to, so we write the fraction here. So numerator becomes secant square A, and denominator becomes 1 plus cot square, so that cosecant square A. Okay, or it's nothing but, so now secant theta is 1 by cos theta. So that is 1 by secant square theta is That is secant square is 1 by cos square A. So let us write that. It's equal to, write the fraction here. And secant square A, as I told you, we can write it as 1 by cos square A. And cosecant square A is nothing but 1 by sin square A. Then it's equal to, so now I can also write in this way also. Let me show you. I can write it as, so 1 by cos square A. Then I put division symbol here. And then I'm going to write 1 by sin square A. So what I did, I wrote instead of that division, this one, no, that bar we write for the fraction. Instead of that, I can write it as division symbol. Okay. So 1 by cos square A divided by 1 by sin square A. Then you should note one thing, that when division is involved, okay, in fractions, we are going to take the reciprocal and convert it into multiplication. So that means in my next step, see what I do. I'm going to write 1 by cos square A, and then this this division sign becomes multiplication sign, and then I'm going to write 1 by sin square A will become sin square A by 1. So it becomes sin square A by 1. It is nothing but, it's equal to, now you get like sin square A by cos square A. Or we can also, so sin by cos is tan, right? So sin A by cos A is tan A. So that way sin square A by cos square A will become tan square A. So we're going to write it as tan square A. So what is the answer now? So option is D here also. Mm, mm. Right? Then I have the next question. Prove the following identities where the angles involved are acute angles for which the expressions are defined. See, we define these trigonometric ratios for the acute angles only. So acute angles are nothing but the angles which are less than 90 degree, okay, and it is greater than 0, okay. They are nothing but acute angles. So now let us see the problems what we have. The first one I have is cosecant theta minus cot theta whole squared equals 1 minus cos theta by 1 plus cos theta. Okay. Now here we have to first identify which one should I consider for solving the problem. So you'll have both LHS and RHS. Sometimes we have to take LHS and sometimes we need to take RHS. Now here, first of all, we have to see which is more complex or which is looking more complex to solve the problems. So here, if I see properly, I feel that the LHS part, that is cosecant theta minus cot theta whole square, seems to be more complex compared to the RHS. So that's why I'm going to take cosecant theta minus cot theta whole square for solving the problem. Okay, so let me take that. LHS equals. So I'm going to write cosecant theta minus cot theta the whole square. So we're going to write like this. Then see here, we should be very careful. We should not expand also. First of all, see here what we have to do. Cosecant theta. So now cosecant theta is nothing but 1 by sine theta. So I'm going to write it as 1 by sine theta minus cot theta is nothing but cos theta by sine theta. Repeat. So cosecant theta is 1 by sine theta and cot theta is cos theta by sine theta. Since we have that whole squared here, I'm going to enclose this first with a bracket, then followed by I need to put a whole square here. So that's why I'm going to put a whole square here, right? Then we can also write it as, I can also write it as, see here, we can also write it as 1 minus cos theta by sine theta, the whole square. So 1 minus cos theta, I just combine this numerator with the common denominator sine theta and then put whole square. Okay. And then, so then what we do is we are going to share this power to both numerator and denominator. So that means a by b whole power m is a power m by b power m. So that means powers can be distributed among numerator and denominator. So here also 1 minus cos theta whole square by sine theta whole square is sine square theta. Okay, so you're going to distribute the power for both numerator and denominator. Then I'm going to write it as, so you know that sine square theta is 1 minus cos square theta. Sine square theta is 1 minus cos square theta. So I'm going to write that sine square theta as 1 minus cos square theta. Then here the numerator becomes like, so what we can do, so whatever the denominator part, it is like a square minus b square. So it is a plus b into a minus b. So that means I can write it as, so I can write it as 1 minus cos theta whole square by 1 minus cos theta into 1 plus cos theta. See here, the 1 minus cos square theta is written as 1 minus cos theta into 1 plus cos theta. That is a plus b into a minus b. Now we can clearly cancel this 1 minus cos theta whole square and 1 minus cos theta. So here when we cancel, see how we should cancel. So just completely cancel this 1 minus cos theta, and here I'm going to cancel only the power 2 and make it as 1. So that means here in the numerator you'll have 1 minus cos theta. Okay. So it's equal to, so then what will happen? So you get 1 minus cos theta by 1 plus cos theta. So 1 minus cos theta, 1 plus cos theta. So is it matching with the RHS? Yes, right now it is matching. So I can mention that as equal to RHS. So this is the answer. So we can hence prove, we can write, find conclusion, we can write it as, if you want, we can write like this, hence proved. Okay. Next we have the question cos A by 1 plus sin A plus 1 plus sin A by cos A equals to 2 secant A. So here also, as I told you earlier, we need to identify the complex terms. So now here, if you see the complex expression, it is present on the left hand side. So the RHS looks simple. So now what I have to do? I have to take the LHS. Okay. Now let us take the LHS part. LHS equals, then we have the question cos A by 1 plus sin A plus 1 plus sin A by cos A. Or I can write it as Now we can do the cross multiplication. So here cos A into cos A. See here how we have to do the cross multiplication. Let me show you. First I need to multiply this denominator. So 1 plus sin A into cos A. And then I have to multiply cos A with cos A. So that is cos square A. And then at the same time 1 plus sin A into 1 plus sin A. So we are going to do like this. Next, now let me write it. So this becomes cos square A plus 1 plus sin A whole square by 1 plus sin A into cos A. I repeat once again. Let me tell you 1 plus sin A into cos A, that is in the denominator. And when you do cross multiplication, cos A into cos A is cos square A. And 1 plus sin A into 1 plus sin A is 1 plus sin A whole squared. Okay. Then I am going to write it as, so now I am going to write it as cos square A here, numerator, plus, now here you have A plus B whole square, that is A square, that is 1, plus B square. So B square is, so we have sin square here, plus 2 sin A. So you get like this, 1 plus sin square A plus 2 sin A, like 2AB, like that it is. Then in the denominator, I am going to write the same thing. Then what we have to do is, so we know that cos square A and sin square A is 1, right children? So here we have cos square A and sin square A together will give you 1. Okay, so let me write it. So that means I get 1 plus 1 plus 2 sin A. So now here cos square A plus sin square A is 1, plus here also there is one more 1 here. I write that one also, plus 2 sin A. Then in the denominator, I write the same thing, no changes here. It's equal to, now this can be done as numerator becomes 2 plus 2 sin A. Right, let me write it. And denominator will be the same. So let me write it. So here I return 2 plus 2 sin A by 1 plus sin A into cos A. Or we can take out the 2 common here in the numerator. We can write it as, it becomes 2 into 1 plus sin A by 1 plus sin A into cos A. Or now we can cancel off 1 plus sin A and 1 plus sin A. One plus sin A and 1 plus sin A cancels. So it's equal to, then we get what? We get 2 cos A. This also nothing but, so it is nothing but, I can also, let me write one more step here because some newcomers will be there, so they not know, understand the problems. So I can write it as, see here 2 into 1 by cos A. Okay. Now you know that 1 by cos A is nothing but secant A. I can write it as 2 secant A. Can write it as 2 secant A equal to, we have, it's equal to RHS. So 2 secant A equals to RHS. So Means proved. We can write a final conclusion. Now we have the third question. Tan theta by 1 minus cot theta plus cot theta by 1 minus tan theta equals 1 plus secant theta into cosecant theta. So for this, first we need to identify which is more looking complex here and which is simple. So now if I look at it, I find that LHS is more complex compared to the RHS. So we are going to consider the LHS part. So now I'm going to consider the LHS. So let us take the LHS. So now we have LHS as tan theta by 1 minus cot theta plus cot theta by 1 minus tan theta. In my next step, what I do is I'm going to write tan theta as sin theta by cos theta. So let us write a fraction now. So let me write the fraction. And here we are going to write tan theta as sin theta by cos theta and 1 minus. Then we have cot theta as cos theta by sin theta plus again cot theta. So we're going to write a fraction again. And in the for cot theta, I'm going to write it as cos theta by sin theta. And then denominator it will be 1 minus. So we have to write tan theta by the tan theta is nothing but sin theta by cos theta. So repeat. So tan theta is written as sin theta by cos theta and cot theta is written as cos theta by sin theta. So I'm going to replace accordingly. Okay. So now in my next step, we are going to write, we are going to solve it. We are going to solve the fraction here. So the fraction in the numerator part remains as it is, no changes. But denominator 1 minus cos theta by sin theta. So just do the cross multiplication here. So when you do the cross multiplication, I get it as sin theta minus cos theta by sin theta. Because sin theta into 1 is sin theta we get. And we have cos theta as it is by sin theta. See, if you don't understand here 1 we can actually write it as 1 by 1. Okay. So now you'll understand. See properly. See 1 into sin theta is sin theta. 1 into sin theta again here also. So here also you get like that. Let me show you. So 1 into sin theta, we get it as sin theta. And then here also 1 into sin theta, this sin theta we get. And 1 into cos theta, we get this cos theta. Okay. So in that way, you're going to get the answer. The next thing we are going to write is, now I'm going to write, so same way, I'm going to write the fraction again. So the numerator remains as it is. It is cos theta by sin theta. And what about the denominator part? So here also the same way I follow. So 1 by 1 I'm going to write it and do the cross multiplication method. Okay. So now let me write a fraction here again. So 1 into cos theta is cos theta. So first part we are going to write it cos theta, the denominator part. And then we are going to write 1 into cos theta. So 1 into cos theta is cos theta. So cos theta minus sin theta. Okay. Then next what we have to do is, so here we are going to multiply. So now here this one. Let me show you very important part. Now this sine theta gets multiplied with this sine theta. So that is the numerator gets multiplied with the denominator of the denominator. So that means here see sine theta and sine theta I'm going to multiply. And one more thing, this cos theta gets multiplied with the sine theta minus cos theta. Okay, now that means sine theta into sine theta, what you get? Sine square theta. So that one you're going to get in the numerator. Okay, so let us write the fraction now here. So I'm going to write the fraction here. So the numerator part becomes sine square theta. So sine into sine is sine theta into sine theta is sine square theta. And right, as I told you, this cos theta multiplied with sine theta minus cos theta. So for this, you're going to write the cos theta. And then you're going to put in brackets sine theta minus cos theta. See, this is a binomial term. That's why you're going to enclose it in bracket. Then plus, then again the same principles you're going to apply. So that means here cos theta into cos theta, you get as cos square theta, right? So we are going to write that. So I'm going to write it as cos square theta. And then here this sine theta part. So the denominator becomes what? Sine theta into, so let me take the sine theta into cos theta minus sine theta. So that means we're going to take this cos theta minus into minus sine theta. So now we got like this. So sine theta into sine theta is sine square theta. This sine theta just multiplied with this cos theta gets multiplied with the sine theta minus cos theta. Similar here also, this cos theta get multiplied, it becomes cos square theta. And this sine theta, this denominator, it gets multiplied with cos theta minus sine theta. So sine theta into cos theta minus sine theta. Now the next part, what we are going to do is, so now if you observe carefully, one thing you notice is that here you have sine theta minus cos theta, whereas this one it's cos theta minus sine theta. Okay. So what I do is I have to make this both of them same or same, both of them I should make it a same thing. Okay. That means here also you should get sine theta minus cos theta. Here also you should get sine theta minus cos theta. That means I need to interchange it. Okay. I need to interchange it. So that means, so we are going to write this sine square theta by cos theta into sine theta minus cos theta. And here we can interchange it as here. So this one, we can write it as, so numerator remains the same. Okay. And here, this when you interchange, no, this plus becomes minus. So that means same thing here, denominator will be sine theta into cos theta, that is sine theta minus cos theta. Okay. So I repeat. So what we did was, here we interchanged sine theta and cos theta. So what rule we applied actually? Let me tell you. So here, remember one thing, a minus b can be written as minus of b minus a. So that means when you interchange, you have to put minus sign. Okay. So the same thing, minus to plus is minus. So only I have written here minus sign. Okay. So here what we did, we interchanged cos theta and sine theta. This is the most important step in this problem. Okay. So now, because otherwise you will not be getting the correct answer. The next part I need to understand. Let me tell you. Now here, still we are not got the same. Only one part is same. But what about this one? We have cos theta and here we have sin theta. I need to make both these denominators as a same. Okay, that means I need to convert both these fractions into equivalent fraction. So what is equivalent fraction? Equivalent fraction is nothing but the denominators will be always same irrespective of the numerator. So that's why what I do is I'm going to make both these denominators equal. So how do you do that? So let me tell you. So now here, let me write this step again. I want to show you how we are going to change this into equivalent fraction. I am going to multiply both numerator and denominator with sine theta. So here, why I should multiply it with sine theta? Let me tell you. When I do like this, so numerator becomes sine theta, sine square theta into sine theta, it becomes sine cube theta. And here you get it as sine theta into cos theta, correct? Similarly, here what we are going to do is in this second part of the fraction, I am going to multiply both numerator and denominator by cos theta. So when I write like that, so cos squared theta into cos theta becomes cos cube theta, and then sin theta into cos theta is sin theta cos theta. Okay, so you got sin theta cos theta into sin theta minus cos theta. Here also you get sin theta into cos theta bracket sin theta minus cos theta. Okay, so let me show you how it looks like. So now I'm going to write it. So now here I'm going to write a fraction, and then what will be the numerator now? As I told you, it is sine cube theta. So let me write that sine cube theta, because sine square theta into sine theta is sine cube theta. And as I told you, sine theta into cos theta is sine theta cos theta. So we're going to write that one. Okay. So I'm going to write it as sine theta into cos theta and then into sine theta minus cos theta. And then I'm going to put minus sign. Similarly, we get cos cube theta by sine theta into cos theta, and then here we have sine theta minus cos theta. Okay. So now you can observe that sin theta minus cos theta into sin theta minus cos theta. So both of them are same. So you got an equivalent fraction. Now next what we can do? We can combine the numerators, correct? So let us do that. So it's equal to, I'm going to write that. So first we are going to write the denominator. So now here, let me take it. Okay, sin theta into cos theta into sin theta minus cos theta. And then numerator, what we combine? That is sin cube theta minus cos cube theta. Very important. Okay. Next. Now here you have like a cube minus b cube. It is of the form a cube minus b cube. You need to factorize it. Okay. Let us write that formula for that. So here I'm going to using the formula using. So I'm going to write the identity a cube minus b cube. So let me write that a cube minus b cube. So the it will be like a minus b into. So now here you're going to write a square plus ab plus b square. Very important formula here. So you're going to write it. So we are going to use this formula over here. So that means Instead of A, you have sine theta, and instead of B, you have cos theta. Okay. So let us write that equals to. So now first A minus B, I'm going to write. Let me write A minus B. So now here, let me write a fraction here. So as I told you, A cube minus B cube. So it is A minus B. A minus B means you're going to write sine theta minus cos theta. Okay. And then open the bracket. What is A square? A square is sine square theta. And then you're going to write, and then we are going to write sine theta into cos theta. So we're going to write that plus b square. So b square is cos square theta. So I'm going to write cos square theta. And then divided by same thing. So I'm going to write sine theta into cos theta into sine theta minus cos theta. Now here you're going to enclose this bracket. You have to put the bracket here. And as you observe, sine theta minus cos theta, sine theta minus cos theta, both of them are same. So it gets cancelled. So we can cancel that. Let's cancel it. So I'm going to cancel here. So sin theta minus cos theta, sin theta minus cos theta gets cancelled. And what you're left out with? Now sin square theta plus cos square theta is identity which is equal to 1, correct? So I'm going to write that. Okay. So let me write that. So I get, so first you're going to write as sin square theta plus cos square theta will become 1. Okay. How means this one? This sin square theta and cos square theta. Both of them combined together, you get it as 1. The next thing, then we have to write plus sin theta into cos theta. And then denominator, you have sin theta into cos theta, because only this is left out in the denominator. Now we can split this fraction. So I can write it as 1 by sin theta into cos theta plus sin theta into cos theta by sin theta into cos theta. So let us do that. I'm going to write it as here 1 by, so I'm going to write it as 1 by sin theta into cos theta plus again. So we can write it as sin theta into cos theta by sin theta into cos theta. Now this is equal to, so you know 1 by sin theta is nothing but cosecant theta, right? Or I'll show you one more step better. Okay. Let me show you one more step. So you can write it as 1 by sin theta into, and here also 1 by cos theta. I'm going to write that step. And then plus sin theta, these things get cancelled, it becomes 1. Okay, both of them are same, right? So it gets cancelled. So I'm going to write it as 1. Now what is 1 by sin theta? It is obviously cosecant theta. So we're going to write cosecant theta into, so for into you can put a dot, and then what is 1 by cos theta? So 1 by cos theta is secant theta plus 1. So cosecant theta into secant theta plus 1. So this is what we require. So see 1 plus secant theta into cosecant theta, the same thing we have got. Okay. So even you can write cosecant theta into secant theta. Okay, it should not be exactly the same. Okay, it is commutative property. I can tell you. So only this expression is correct. So now we got the, this is nothing but it's equal to LHS. Then so this one, now we got this cosecant theta and secant theta plus 1. So finally we got it is, man, it is verified now. So now this is equal to RHS. So finally we got it as, so this is nothing but it is equal to RHS. Hence proved. Can write like this, hence proved. Now I go for the next question, the fourth question. 1 plus secant theta by 1 plus secant A by secant A equals to sine square A by 1 minus cos A. Let us take this problem. For this, see here, one thing I want to tell you, how we have to identify complex and simple. Here what we do is, I assume that this sine square is, sine square, yeah. So it is more complex than this one, okay, from compared to the LHS. So only I'm going to take sine square A by 1 minus cos A as more for solving this problem. So I start with the RHS. Okay, so let us take the RHS. So we're going to write like this. So RHS, let us write it. So RHS. Now in my next step, what is sine square A? So you should note that sine square is nothing but 1 minus cos square A. So we are going to write that. So I'm going to write it as 1 minus cos square A. So let us write that. 1 minus cos square A by, and denominator will be as it is, 1 minus cos A. In my next step, we are going to, now here it's like A square minus B square. It is like A square minus B square. So that means here you can write it as 1 minus cos A into 1 plus cos A. So numerator, you can actually write it as 1 minus cos into 1 plus cos A, because 1 square is 1 only. So as such, you can write it as 1 minus cos A into 1 plus cos A, and denominator will be 1 minus cos A. Now here if you observe carefully, 1 minus cos A, 1 minus cos A gets cancelled, right? So that means you'll be left out with what? So you're left out with 1 plus cos A. So it's equal to 1 plus cos A. So we're going to write as 1 plus cos A. Or, but our LHS part is 1 plus secant A by secant A. So how to change from cos A to secant A? So obviously we have to take the reciprocal. So we're going to write that. So we know that it's equal to 1 plus. Now cos A, I can write it as 1 by secant A. So 1 by secant A. Now you can write this one as 1 by 1. Okay. So 1 by 1. Put the cross multiplication method. So 1 into secant A, and secant A into 1 is secant A plus 1. Correct? So I can write it as, it's equal to, so denominator will be secant A. First let us write that. And 1 into secant A is what? Secant A plus 1. Now this is nothing but what? Now this is equal to, so now secant A, same thing. So it is equal to LHS. So let us write that. It's equal to LHS. Hence proved. That's it. Now I go for the next question. So we have the next question as cos A minus sin A plus 1 by cos A plus sin A minus 1, which is equal to cosecant A plus cot A. Now, when you look at this problem, you will only come to know which is more complex and which is more simple. So by looking at this, you can easily tell that we have to take LHS because that looks more complex, right? So I'm going to take the LHS part. So let us take that. I'm going to take that LHS. This is nothing but cos A minus sin A by plus 1 by cos A plus sin A minus 1. Next, what we do is here, there is one special step that you need to remember always. So you need to practice this problem many times before you can expertise it. Okay. So now dividing both numerator and denominator by sin A, we get. So we are going to divide both numerator and denominator by sin A. Okay. For this, let us write a fraction here. It's equal to. Now I'm going to write the fraction. See here also again I'm going to add on fraction here. And denominator also I'm going to add on fraction. So now here, look at this, very important one. So now you're actually dividing this cos A minus sin A plus 1 by sin A, correct? So you are writing this fraction here. So first the numerator part is written here, okay? And you're dividing by what? Sin A, okay? Then what you have? Cos A plus sin A minus 1, that is in the denominator, that is in denominator, write that cos A plus sin A minus 1. Again, you are dividing by what? You are dividing by sin A. See how it is? So as I told you, cos A minus sin A plus 1 by sin A, cos A plus sin A minus 1 by sin A. Then what we write is, we can split it. So that means we are going to write the fraction again. So let us write the fraction. I can write it as cos A by sin A, then minus sin A by sin A, and then 1 plus sin A plus 1 by sin A. Then here also denominator, again cos A by sin A, we get, and then we get sin A by sin A, and then minus 1 by sin A. Then, now you know cos A minus cos A by sin A is nothing but cot A, right children? So we are going to write that. For that, let me write the fraction. So cos A by sin A is cot A. So cot A minus, then sin A by sin A is 1. Okay. Then plus, then you have cosecant A because 1 by sin A is cosecant A. Denominator, again you're going to write as, so cos A by sin A is cot A. Plus sin A by sin A is, it is 1. Then minus cosecant A. We're going to write that. Then I'm going to rearrange the terms in the numerator. So rearranging the terms in the numerator, we have, I'm going to write it as, here, would write the fraction first. Numerator will be written as cot A plus cosecant A minus 1. And denominator, you're going to write the same thing, that is cot A plus 1 minus cosecant A. Okay. Now we know that cosecant square A equals 1 plus cot square A. So cosecant square is 1 plus cot square A. Or cosecant square minus cot square A, it will be equal to 1. So that means we get cosecant square A minus cot square A, you get it as 1. So now I'm going to substitute the value of 1 in the numerator. So now here you have this 1 which is being substituted. So that 1, see what I'm going to write now. See. So for this, we are going to write the fraction here. I'm going to write it cot A plus 1. Okay. First one. But what about the minus 1? That minus 1 part, no? You're going to write it as cosecant square A minus cot square A. And denominator will be the same thing. Cot A plus 1 minus cosecant A. Now it's equal to. So you're going to write it as. So now here, again, let us write the fraction here. I'm going to write this, but enclose it in bracket now. Then minus you have. Now cosecant square A minus cot square A. So you can write as it is like A square minus B square formula, A minus B into A plus B. So I can write it here. A is cosecant A and B is cot A. So that means I can write it as cosecant A minus cot A into cosecant A plus cot A by denominator will be the same, no changes. Then here if you notice one thing, I can tell you that this cosecant A plus cot A, this one, the highlighted one I'm going to highlight it better. So here we are going to highlight it. So this cosecant A, so this dot highlighter, let me take highlighter here. So you can see that cosecant A plus cot A, cosecant plus cot A is same. So that means we can take out cosecant A plus cot A as common. Okay, so let us write that. I'm going to write a fraction here. Okay, and cot A plus cosecant A, you're going to write that into bracket open. Now, what about this part? This part becomes 1 now. As soon as you take out 1 as common, so what will happen in numerator? Numerator it becomes 1. 1 minus, what is left out here? Cosecant A minus cot A. Okay, and here, let me use a square bracket to distinguish the brackets. And denominator, you write it as cot A plus 1 minus cosecant A. Okay, now I'm going to write again the fraction here. In the numerator, you're going to write like this, cot A plus cosecant A. And here, square bracket, 1 minus So you get 1 minus cosecant A plus cot A. Because 1 minus cosecant A plus cot A, bracket close, divided by cot A plus 1 by cosecant A. Okay, or it's equal to, now if you look at it properly, here one thing you notice is that see here we have 1 and 1 same thing, same sign. Here you have plus cot A, here also plus cot A only, and here you have minus cosecant A, minus cosecant A. So that means we can cancel this and this, the one highlighted in a yellow color. So I'm going to cancel this. So what is left out now? So that means what is left out is cot A plus cosecant A. So we're going to write that, or it's equal to, let me erase this, or it's equal to cot A plus cosecant A is what we require in the RHS. So which is equal to RHS.